For one thing, in the Standard Model, there is a somewhat mysterious list of particles that appear in this theory as elementary particles. Among them are quarks. Two kinds of quarks. The lightest ones make up the protons and neutrons, which in turn make up atomic nuclei. 3 quarks in each proton or each neutron. But there are altogether 6 types of quarks. The other 4 are heavy and unstable. They're all equally important as far as the Standard Model is concerned. It's just an accident that 2 of them are the ones that appear in ordinary matter. There are other particles. There's the electron, and it has a couple of siblings, which are just like the electron, but heavier and also unstable. Now, we have a table based on experimental data of the properties of these particles, their masses especially. And we know what their masses are. But we don't know why they are. We've been looking at this table of experimental information about these masses now for several decades with the feeling that it's got to be telling us something, and we don't know what it's telling us. It's a little bit like having a manuscript in a, say, linear A, a language that hasn't been deciphered. You feel you ought to know what it's saying, but you don't know what it's saying. Another thing, astronomers tell us that 5/6 of the matter of the universe is some kind of dark matter, which was discussed already in a panel in this festival. This dark matter, none of the particles of the Standard Model have the right properties to make up the dark matter. So 5/6 of the mass of the universe is not in the form of anything described by the Standard Model. Well, it's something we ought to know more about. And finally, there's a little technical detail that gravity doesn't fit in the Standard Model. It's also something we would like to know more about.